All right, so talk about moles. And what moles builds on is the concept that we talked about in the previous video, which is atomic weight. And the way I'm going to illustrate this is basically we're going to say we have 1 gram of copper. We're going to say we have 1 gram of iron. So the atomic mass of iron is 55.85 AMU. And the atomic mass of copper is 63.55 AMU. So we see right away that the mass of copper is more than that or greater than that of iron. So if we have 1 gram of each of these substances, it would make sense that there would be more iron atoms in 1 gram than there would be copper atoms in 1 gram. Because if iron is lighter, it would take more of them to equate to 1 gram, right? So this is why the concept of atomic weight is important when going into moles, because the atomic weight is representative of each individual atom, right? And atoms are going to have different weights. So what moles then does is it creates this concept of equivalence between atoms. So if we were to convert iron and copper both to moles right now, you would have more moles of iron than you would copper. And the reason is moles is defined by a specific number of atoms, right? So the way we do that is we say 1 mole, and the abbreviation for mole is MOL, is equal to 6.022 times 10 to the 23rd atoms. And this was done, this number was chosen because if we go and we want to know how many atomic units are in 1 gram, right? So 1 gram is actually equal to 6.022 times 10 to the 23 atomic units. So the reason that this is significant and the reason moles is defined in this way is because if we want to find out how many grams of iron, let's choose iron in this case, there are in 1 mole, well, let's start with this. We have 55.85 AMU in, sorry, in 1 atom of iron, right? Well, if that's true, we know that there's 6.022 times 10 to the 23rd atoms in 1 mole, right? So now we know that we could get rid of atoms, right? So we're going to be left with 55.85 AMUs per 1 mole, and it's going to be times this proportionality constant. But we're not done yet. What if we want to get rid of AMU? Well, we know that for every 6.022 times 10 to the 23rd AMU, we have 1 gram, right? Well, this now gets rid of AMUs, and we can also cross out the proportionality constants. So this tells us right here that 55.85, all that's left are grams per mole, and this is for iron, right? So we have 55.85 grams in 1 mole of iron is what that is telling us. So this tells us the atomic mass from the periodic table is the amount of grams we need to have 1 mole of that substance. And that is very important, okay? So the next thing we can do is kind of say, okay, well, how can I use this? And if we had, let's say, X grams, we're going to make this red, just X grams of iron, right? Well, now we know for every 55.85 grams of iron, right? we get 1 mole of iron, right? This is just unit analysis, right? So here we can cross out grams of iron, and what you would be left with is this value divided by 55.85 is equal to 1 mole of iron. Well, we know that if we have 1 over grams per mole, this is unit equivalence, right, through math. This is just moles per gram, right? So that means that this right here, this whole dimensional analysis we just did, tells us that, N, which we say is the number of moles, is equal to mass over molar mass. That's what we get from this, right? Because effectively, this is saying X, which is the mass in our case, right? We're going to say this guy right here is our M, divided by this quantity right here, which is our molar mass, is going to give us our number of moles. So this is mass, and it's either measured or given. So if you were in the lab, you'd measure it. And if you were doing a textbook problem, it would be given. This is molar mass. And this is number of moles. Right? So it's that simple. Basically, what you need to get out of this is that moles are a fixed number of atom that we've defined as 6.022 times 10 to the 23rd. And what that does is it gives us a concept of equivalence for atomic masses to get a number of moles. And the way to calculate that is just the mass that you're given or that you measure divided by the molar mass.